There's your thought for the day. We're going to cover Chapter 6 on similarity. Okay, a problem-solving strategy for this is to solve an equation, solve a problem. So let me take a look at so what you've got here is here's a type of problem we'll do in this chapter where you can use an equation. We've got an aerial photograph of this river. We know that the dam, this dam is 100 meters long, it's 3 centimeters long in the picture. We need to know the length of the second dam. All we know is its length in the picture, we don't know its actual length. We can use an equation to solve that. Okay? We can use an equation of proportionality to solve that. Everybody know how I would set it up? How could we set it up to find the length of the longer dam, the actual length?
You could do 100 equals 3, and x equals 1.7.
Oh, wait. You wouldn't do it. Say again?
100 equals 3. 100 meters equals 3 centimeters. And like 100 down, x equals.
Okay, so create proportions, right?
Yeah.
So you've got 3 on top, so you have 100 on top here. And then
So much easier.
5.7 and x, is that what you're saying?
Yeah.
Yeah. Okay, cross multiply, so that would find the missing length. That's the type of thing we'll do in this chapter. Alright, very good.
I don't like what?
Okay, so geometric figures that have the same shape but not necessarily the same size are said to be similar. Same shape but not the same size, they're similar. Ratios and proportions are objectives. We're going to use ratios and proportions to find missing values. A ratio is an ordered pair of numbers. The ratio of a number A to B can be represented in 3 common ways. Alright? Anybody know the 3 ways to express a ratio? Shatis?
A fraction, an actual ratio, and I don't know the third one.
Okay, well you covered one of them. That would be A over B, where B equals not 0, as a fraction. Anybody else know another way to express a ratio? Okay, so we have A to B. Alright, just writing A to B like that, or then you can do A colon B. Those are both ratios. For the rectangle, calculate the following ratios.
So when I calculate the ratios, we're going to say, so they went length to width. We'll call 24 inches the length. So we have 24 inches over 10 inches. But I've got to reduce it. You're not done until you reduce it. So the ratio, 2 goes into both of those. It'd be 12 over 5. The units cancel, right? So we can drop the inches. We're just concerned about quantity to quantity. So it'd be 12 over 5. What would be the ratio of width to length? Shatice?
10 inches by 24 inches, which would reduce to 5 by 12.
Yeah, so we'd have 10 inches over 24 inches, which equals 5 over 12. All right. Length of the diagonal of the length of the diagonal to the perimeter. How would I find the length of the diagonal? Ahitya? Yeah, we do the Pythagorean theorem. So we would have the square root of 10 squared plus 24 squared divided by the perimeter, which would be 10 times 2 plus 24 times 2, or 20 plus 48. Let's go over to the side. Let's go up here to the top and solve this Pythagorean theorem. So we'd have 10 squared is 100, so we'd have 100, and 24 squared is 576. Right, so the square root of all that is 676, which equals to 26.
We have also used, like, since it's like a multiple of 5, 12, 13.
Yeah, you could do 5, 12, 13 and multiply times 2. Yeah, that's one of the ratios. Yep. So we'd have 26 over, and then 20 plus 48 is 68. I'm not done yet. Why not? What do I have to do? Yeah, we got to reduce. So it'd be equals to 13 over 34. Questions? All right. Perimeter to area. Okay, if we did perimeter to area, we know the perimeter. What was the perimeter? Shatice?
68.
Yeah, their perimeter was 68 inches, so we have 68 inches over. What's the area? Somebody else. Nina.
240.
Yeah, 240 inches squared. So then, now, since I don't have the same units, the units don't cancel. Right? So we would just have, we'd reduce the numbers. 4 goes into both of those. So it'd be 17 inches over 60 inches squared. All right, questions? Now, when we have two different units, like we did on the last one, those are called rates. All right, it's called a rate when we have two different units. Other examples of rates would be 12 miles per hour. Right, miles on top, hours on the bottom. 5% per year. So we have percent and then year. $3.69 per pound. Dollars per pound, right? Those are all rates. The proportion. Your proportion is an equation stating that two ratios are equal. The proportion is an equation stating that two ratios are equal. Okay, we're going to show the following our proportions. What do I have to do to show that this is a proportion? Ben? That hit you? Well, that's one way, but I could simply, we have to show the ratios are the same so we could, Nina? Yeah, we could reduce. We could reduce that, and we could say 2/4 equals 1/2. All right. How can I show that 3.2 over 4.8 equals 2 over 3? Shatiz.
Would you not cross multiply in this case?
You don't have to. Not yet. You guys are getting ahead of me. You're stealing my thunder. All right. What can I do? What goes into 3.2 and 4.8? Both. Zach? Yeah. How many times does it go in 3.2? Yeah. It reduces to 2 over 3 as well. It goes into 4.8 3 times. So that'll work. Okay. The next one. Let's rewrite it as fractions. Pi over 3 pi is equal to 1 over 3. Right? So, Shatiz?
We can simplify because the pies will cancel each other.
Yeah, the pi's cancel and you'd have 1/3 equals 1/3. D, same idea. The x's would cancel. 7/5 equals 7/5. Everybody got it? All right. Write a proportion. When a proportion is written as A over B equals C over D, the numbers A, B, C, and D are called the terms. Okay, those are the terms of the proportion. The two numbers A and D are called the extremes. They're the extremes because when you name the proportion, it's the first and last thing you say. A is to B as C is to D. A comes first, D comes last. They're the extremes. B and C, the ones that come in the middle, are called the means. We have to determine if this is a proportion. Okay, now we can do as we did before. And 10 over 15 reduces to what?
2/3.
Yeah, it reduces to 2 over 3. And 8 over 12 reduces to what? Madeline? Yeah, 4 goes into both of those, so it'd be 2 over 3. So that's one way we could say that that is a proportion. 2 over 3 equals 2 over 3. Now what you guys were trying to get me to do before is the other way to show that this is a proportion. Really, this should have a, since we don't know this is equal, there should be a question mark above it. Okay? Because it's not a true statement until we know it's equal for sure, right? But then, yeah, like you said, we can cross multiply. We can cross multiply to get our proportion. So to show that it's a proportion if the sides equal. So we take 10 times 12 is equal to 15 times 8. So that's going to be 120. is equal to 120. So then we have yes, that is a proportion. Any questions? That leads us to the cross multiplication theorem. A over B equals C over D if and only if the product of the means equals the product of the extremes. Product means multiplication, so the extremes are A times D and the means are B times C. Proof of the cross multiplication theorem. Prove that if AD equals BC, then A over B equals C over D. Sub-goal 2. Prove that if A over B equals C over D, then AD equals BC. We'll prove the sub-goal here and leave sub-goal 2 for the problem set. Okay, so to prove that if A times D equals B times C, then A over B equals C times D. Our proof is that we can divide both sides of the equation by the same non-zero number, BD. So we would divide both sides by BD, and we would obtain AD over BD is equal to BC over BD. And simplifying, we would have the D's cancel and the B's cancel. We would have A over B equals C over D. Do I get it? Right. Now, using theorem 6.1, we can see that 3 over 5 equals 6 over 10 because when we cross multiply, they're equal. We can interchange various terms of this proportion to form new proportions. So we can write we can exchange the extremes. Right? You just take the original proportion and we exchange the place of 10 and 3. You can do that. You're cross multiplying, right? Anything, if you're cross multiplying and they're multiplied times themselves, then you can exchange them. Same thing for the means. We can exchange the position of 5 and 6 because you're multiplying them times each other. That's not going to affect it. Okay? Or you can flip both the fractions. If we flipped it and make the 3/5 5/3 and the 6/10 10/6, those are also going to be same ratios. Everybody got it? So that leads us to this theorem. In the first one, we're exchanging the extremes. We're exchanging A and D. In the second one, we're going to exchange the means. So what would my fraction read? A over B equals C over D if and only if what? We're exchanging the means. Chatice.
A over C equals B over D.
Right, A over C equals B over D. Okay, and then the invert. If I invert them, what would it read, Lily?
So it would be B over A equals D over C.
B over A equals D over C, correct. Example, determine if 21 over 35 equals 27 over 45 is a proportion. Okay, we have to determine if that is a proportion. How do we do it? T.
B?
No.
Cross multiply?
Cross multiply. Yeah, so it would be 21 over 45 equals question mark 35 over 27. So that would be 945 equals 945. Check. And that's yes. So it is a proportion. We can use cross multiplication to solve for a missing term in a proportion. Right? So now we have to find y. To do this, I cross multiply. So we're going to have 14y equals 17 times 42. So then 14y equals 714. So y equals 51. Do the second one on your own and reduce the fraction. Okay, should look like this. So we would have 42 times x equals 31 times 7. So that would be 42x equals 217. So x equals 217 divided by 42, which is equal to 31 times 7 over, because 7 goes into both, 6 times 7, so that's going to be 31 over 6 is our answer. Questions? Okay. Example 6.6. A rectangular snapshot measures 3.5 inches by 5 inches. Y. An enlargement photo will be made. The larger photo will have a width of 18. Another original picture will be cropped or left out. The dimensions of the enlarged are proportional to the dimensions of the original. What would be the height of the larger photograph? This is very similar to the very first question that I showed you at the beginning of the chapter. It's using the same idea. So, how would I solve for x? Lexi Hoskins. How would I solve for x? Yeah, so what would my fraction read? 5 over 3.5 equals 18 over x. You can set it up that way. There's a number of ways you can set it up, but we can set it that way. So then we cross multiply, and we're going to get 5x equals 18 times 3.5. So 5x equals 63. So x equals 12.6 inches. Questions? Okay, the geometric mean. The arithmetic mean, or average, of two numbers, we know that. What do you do to find the mean of two numbers? The arithmetic mean, what do you do? Shatice?
A plus C divided by 2.
Yeah, we take a plus c divided by 2. The geometric mean, or mean proportion, of A and C is the square root of AC for positive AC. Consider the proportion A over B equals B over C. Here we have AC equals B squared, or B equals the square root of AC. So the geometric mean, don't make it harder than it is. You are to find the geometric mean of two numbers. Okay? You're going to multiply them and take their square root. So we've got, in the example, find the geometric mean of 3 and 27. Alright, so we're going to say 3 over x equals x over 27. So that gives me x squared equals 3 times 27. So x squared equals 81. X equals 9. Now, rather than set up a proportion like that, I will accept this. You can just say x equals the square root of 3 times 27 if they ask you for the geometric mean. Because remember, for average, to find the arithmetic mean or average, you add the numbers, divide by 2. To find the geometric mean, you multiply the two numbers and take their square root. Okay, that's what you're doing. Don't make it harder than it is. Okay? Multiply the numbers, take their square root to find the geometric mean. Questions? Geometry around us. The golden ratio, also called the divine proportion, was known to the Pythagoreans in 500 BCE. This ratio, the number 1 plus radical 5 divided by 2, occurs frequently in nature, art, and architecture. Okay, this ratio is pleasing to the eye. That's why they used it. The Parthenon in Athens can be surrounded by a rectangle whose sides have length and width in the golden ratio. The Greeks believed that a rectangle with the sides in this ratio had the most aesthetically pleasing shape. So, if you ever go to Greece and you look at the buildings and you look at them, you can observe or you can see and think, okay, that's the golden ratio. Those buildings look good because they have a ratio they determine is pleasing to the eye. This 1 plus radical 5 over 2. The golden ratio. Alright, any questions on the notes? Very good.